Hello, welcome to the Maths Matrix and part 3 in the percentage series. My name's Rebecca and in this video we're going to be doing repeated percentage change, which is also known as compound interest, compound growth and decay, or exponential growth and decay. You'll be needing paper, pen and a calculator, and you'll need to know how to find a percentage of a quantity and how to increase and decrease by a given percentage. I'm going to pop some questions on screen in a minute, and if you know that you would be able to do all of those questions, then you don't need to watch this video, you can just move on to the next one. If you're not sure how to do them, then stick with the video and that's what we'll cover now. Here are the questions. If you're still here, then I'm assuming there were some questions there that you didn't know how to do, so let's get started. Assuming that you did the other videos in this series already, continue on with your notes and just put a subtitle of Type 4 Repeated Percentage Change. And then in brackets just put also known as compound interest, compound growth and decay, etc. And then put, e.g., I invest £10,000 into a savings account that pays 2% compound interest per annum. How much money will be in the savings account at the end of 3 years? All right. And then just put method 1, non-calc. Now these are quite long-winded without a calculator, so they will usually appear on a calculator paper, but occasionally you'll get a smaller one to do on a non-calculator paper, so it's worthwhile having a look at it without a calculator as well. I also think if people have a look at one without a calculator, they understand more thoroughly what compound interest actually is. So we'll do it first without a calculator, the slow way, and then we'll look at the calculator method, which uses a much quicker formula. All right? Per annum just means every year, and you might see that on exams. So if you do, don't worry about it. It's just Latin, meaning for every year. So this question said that we were putting £10,000 into a bank account that was going to pay 2% interest every year, in other words, and how much would there be at the end of 3 years? Well, first of all, for the first year, we would have 2% of £10,000. So 10% would equal £1,000. So 1% would equal £100. So 2% would equal £200. And in the first year, at the end of the first year, you'll have all £10,000 that you put in and that extra 2%. So you'll have 10,000 plus 200, which will equal £10,200 at the end of year one. The common mistake that people tend to make is they then say, right, well, after 2 years, you must add an extra £200 on again, which would give me £10,400. And at the end of 3 years, you'd need to add another £200 on, which would be £10,600. So after 3 years, you'd have £10,600. That is not the case. That I've just described is not compound interest, that's simple interest. So simple interest, which are also sometimes asked about, is the mistake that people make when they're trying to do compound interest, and we'll put a note to that effect after if I remember. So what you actually need to do is in the second year, you're going to get 2% interest. But because it's compound interest, you're going to get 2% of that added on. So we would first of all find 10%, which would be 102 this time, because we're finding 2% of that this time, not of that. So 1020 would be 10%. So 1% would be 102. So 2% would be 204. So that after 2 years, you would have that from first year plus that £204 interest, which would give you £10404. Okay. I'm going to have to turn over because I've run out of space. So after 2 years, we have £10404. In our third year, we would then have 2% of that added on. So 10% would be 1040.4, and as his currency, that would be pounds and pence. So 1% would be 104.04. So 2% would be 208.08. And so after 3 years, you'd have 10404 from second year, plus that 2%, which would be, just write it underneath for ease, 1601, which would be £10,612.08. Okay, so for compound interest, if you're asked to do it without a calculator, it's quite slow because you've got to find the given percent of the original amount and add that on to make your first year or your first week or your first whatever time period they're on about. And then you've got to find the percentage of that new figure and add that on. And then you've got to find the percentage of that new figure and add that on. So you've got all this to do every time and a new add every time. And that's how compound interest is done. And that's the non-calculator method. All right. You're not often asked to use the non-calculator method. And if you are, they would never do more than 3 repetitions, I don't think. So first year, second year, third year, like I've just done. I'd be very surprised if they ever asked for more repetitions than that nowadays, just because it is time consuming. Okay. You'll be pleased to know that with a calculator, it's much faster. So if you now put method 2, calc, and then just put, use the formula original amount times multiplier And then we're going to put to the power period of time. So you want original amount times by multiplier, and then in the air, as if you were writing, you know, when you write x cubed, you write the 3 small in the air at the side of the x. That's what we're doing here. Original amount times multiplier, and then period of time is in the air like a power. And that's the formula that you can use. I'll have to turn over again because I'm running out of space. So I'll just copy that formula down again so that I can show you how it's used. So in your notes, you'll have used the formula original amount times multiplier to the power period of time. And then put e.g. and copy the same question down as before. So I invest £10,000 into a bank that pays 2% compound interest per annum how much will I have after 3 years? Now, thinking back from the percentage increase and decrease video, the calculator method for that, we said if something was increasing, that meant we were going to have 100% plus the extra percent that was being added on. And compound interest is a thing in terms of a savings account that's added on. It's a good thing, you get extra. So that's going to give 102% in this case because it's 2% compound interest. And converted into a decimal, that's 1.02. And that is what we're going to use as our multiplier. And it's really important to convert it to a decimal first, or else you'll get the wrong answer. People sometimes forget to convert it to a decimal, but you must, or else you'll get the wrong answer. Or if you prefer the fractions method, then the multiplier will be 102 over 100 if you want to use a fraction instead. But this is much slicker in the calculator. After you've worked out your multiplier, it is super simple. It's just a case then of using that formula. So the original amount is 10,000, the multiplier is 1.02, and the period of time in the question is 3. So we'll do 10,000 times 1.02 to the power 3, and that will just go into the calculator. All right, I'll put it in my calculator and then I'll show you. In fact, I'll come and show you if I can what I'm pressing so that you can see. So 10,000 times 1.02. And then if you see that button there, let me try and get it to focus. There's a little X with a square above it. And that little square allows you to put in a power of your own. So I'll press that little X with the square button, not the X squared. On my calculator it's at the side and it's X with a blank square. And now I've pressed that, what my calculator's done is it's put a little square in the air next to the 1.02. I'll just put a 3 there now, so that I have 10,000 times 1.2 to the power 3 on my calculator. Exactly like what I've written there, okay? And now I just press equals. It's given me one of those fraction answers. So I'll press my S to D button to change it into a decimal. And it's converted that now into a decimal for me. And I have 10612.08, just like I got when I did it without a calculator using method 1. All right, so So it's really easy with a calculator. You just think, what percent do I need? So 100% plus whatever extra you're getting. Convert it to a multiplier and use the formula original amount times multiplier to the power period of time. All right? So let's do another one. And this time we'll just do it with a calculator because they almost always are on calculator papers. So put e.g. in 2005, a company had a turnover of £75,000. Each year, this turnover increases by 12%. What will the company's turnover be 5 years later? All right. So in this case, we have 100%, and because the turnover is increasing by 12%, we add 12% on. So every year the company's going to have a turnover of that plus 12% extra. So that's going to give 112%, which as a decimal is 1.12, and that's our multiplier. Or if you're using a fraction, 112 over 100. Using the formula, we then have the original amount, 75,000, times by that multiplier, to the power period of time, which in this case is 5 because the question says 5 years later. And then that just goes into the calculator like before. So I'll bring the calculator up again and I'm going to put 75,000 times 1.12. I'm going to press the little X with a square next to it to send a square up there next to the 1.12, and in that square I put 5, so that now what I've got in my calculator looks like that, and I press equals, and that gives me 132,175.63 to the nearest penny. Okay, so once you know the formula, it's super simple on a calculator because you just have 100% plus the extra percent that's going to be added on each year. You change it into a decimal and that gives you your multiplier, and then you just plug everything into the formula. So if I were you in your notes where you've got that formula, I'd put some kind of bubble around it or highlight it in some way so that it really stands out, because you have to know that they don't give it to you on a formula sheet. So that's something that you must learn. All right. Now let's do one where the amount goes down every year. So if you put e.g. a car is purchased brand new for £21,000. each year it depreciates by 6%. How much will the car be worth after 7 years? Now this is done using the same formula as before, except the way we get our multiplier is using a takeaway instead of an add. So depreciates means goes down in value, and that's a word you might see on an exam. So it just means decreases, devalues, gets worse in some way. So the multiplier in this case is going to be 100% minus 6%, because the car is losing 6% of its value every year, which means that every year there's only going to be 94% of its value left, which is going to give us a decimal of 0.94. And that will be our multiplier in this case. Remember I said in the last video that where you have a decrease, a percentage decrease, you have a 0 point multiplier because you only have part of it left. So for an increase, you generally have a 1 point something, and 1 looks like I for increase. And if you have a percentage decrease, then you have 0 point something, which looks like O, for there's only some of it left. So in this case, it's 0.94 because there's only 94% of that value left after first year, and then 94% of that left after second year, and so on. After that, it's just a case of using the formula again. So 21,000 is the original value, times by the multiplier, which is 0.94, to the power period of time, which is 7, and that just goes into the calculator like before. So I'll put 21,000 times 0.94, press the little X with a square button, put 7 in the little square, and that gives me an answer of £13,618.03 to the nearest penny. Okay. These questions are generally quite easy to spot on exams because they're referring to a percentage that's happening again and again over a certain period of time. So it could be that it's happening every week or every month or every year, but a percentage will be applied every so much period of time. And that's why it's called repeated percentage change, because that percentage change is being repeated every month or every year or whatever. So they're quite easy really to see on exams, and as long as you know the formula on a calculator paper, then the hardest bit really apart from that is knowing how to calculate your multiplier. They're often in the context of money into savings accounts, but not necessarily. So it could be money into a savings account that pays this % compound interest per annum, meaning every year. It could be cars going down in value by a certain % every year. It might also be things like populations increasing by a certain % each year, or decreasing by a certain % each year, or sometimes even each minute or each hour if it's perhaps in a lab to do with bacteria or something like that. And that's how you do compound interest. I said I'd talk to you a bit about simple interest as well. So in your notes, just put simple interest and then put simple interest is the mistake people make when they are trying to do compound interest. E.g., £10,000 is invested into a savings account that pays 3% simple interest per annum, how much money will be in the savings account after 5 years? All right. Now for this one, we would say 10% equals £1,000. So 1% equals £100. So 3% equals £300. So that would mean that £300 interest would be paid. For simple interest, that's the amount of interest that's paid every year. So all we would do now is the mistake that people make when they're trying to do compound interest. All we would do now is times 300 by the 5 years, which would give us £1,500. And that £1,500 would then get added onto that £10,000 to give us £11,500. So simple interest really is simple. You do just find the percent that they're on about and then multiply it by whatever time period they're on about. So it's the thing that people get wrong when they're trying to do compound interest. Because if instead of simple interest, this had said compound interest, then we would have used the formula 10,000 times by, well, 3% more would have given us 103%, which would have given us 1.03. So we would have had 1.03 as our multiplier and 5 to our time as our time period. And that would have gone in the calculator to produce an answer of £11,592.74. All right. You don't often get simple interest questions, or you didn't until fairly recently. You almost always get a compound interest or compound growth of some description question on an exam. So it is one of the types of percentage that's definitely worth knowing. It could be a fairly straightforward one for 3 marks, or it could be in a compare and contrast kind of scenario as a 5 marker. If you can be able to do it without a calculator as well as with a calculator, just in case they give you a shorter one to do on a non-calculator paper. But if you can't, if you're either stuck for time or you're just not that confident with percent and you just want to learn some of it well rather than all of it badly, then at least make sure that you know the formula version, because that almost always comes up. All right? So I'm going to put the questions from the beginning back on the screen again, and hopefully now you'll be able to do them. You can use a calculator for all of them in this case, and then I'll put the solutions up as well after so that you'll be able to mark them. All right? Thank you very much for watching this video. I hope you found it useful. If you did, please consider subscribing or leaving me a thumbs up, and I will see you in the next one where we'll be doing... What will we be doing? What's it called? Thank you very much for watching this video. I hope you found it useful. If you did, please consider subscribing to the channel or leaving me a thumbs up, and I'll see you next time where we'll be doing expressing one quantity as a percentage of another and calculating a percentage increase, decrease or change that has already occurred. See you next time.